The learning goals for this lesson are for you to understand preference voting, to determine the winner of an election when using different types of voting methods such as plurality, Borda count, plurality with elimination, pairwise comparison, and for you to determine the fairness of each method. To begin, let's look at this brain activator. 7 children attend the same daycare center. Each vertex in the graph represents a child. An edge between 2 children indicates that they tend to cause problems when they are in the same playgroup. What is the minimum number of playgroups that will ensure no conflicts arise? You will want to pause the video while you work on this brain activator. When you've finished, resume the video. Let's do a quick check of your work. This is a conflict problem, and recall that conflict problems can be solved with graph coloring. The first step is to find the valences of each of the vertices. Here you see the valences of the vertices listed for you. Recall that to find the valence of vertex A, you check to see how many edges intersect at A. There are 3, and therefore the valence of A is 3, and so on for the rest of the vertices. The second step is to put the valences in order from high to low. Notice that we have 2 vertices, B and D, that both have a valence of 5. Doesn't matter which of these vertices we start with. I just choose to go in alphabetic order so that I don't overlook any of my vertices. The same sort of thing is true for vertices A, C, E, and F. Each of those has a valence of 3, and again I've just shown those in alphabetic order. G is the lone vertex with valence 2. Now what we're going to do is work our way down from the high to the low, and we're going to begin coloring with the first uncolored vertex. B is our first uncolored vertex. Let's color it red. Now we want to check to see if the next vertex in order is connected directly with B. D, it looks like it might be connected to B. It is in the sense that there's a path from B to D, but there is no single edge that joins the two. And therefore D can be colored red as well. Looking down the rest of the list, you'll notice that each of the other vertices, A, C, E, F, and G, are all directly connected to both B and D. Therefore, none of these vertices can be colored red. Now we'll start the process over again with the first uncolored vertex. This time it's A. We can choose a color for A and then check the next vertex below it to see if it can have the same color as A. Checking C, notice that A and C are directly connected. A and E, however, are not, so E can be colored the same as A. F is connected to E, so it cannot be colored green. And then we'd look at G, and it can be colored green because it's connected to neither A nor E. Starting up at the next uncolored vertex, that's C, we have to color it a different color, which is blue, and notice that the only uncolored vertex at this point is F. F is not directly connected to C, and therefore it can have the same color. So the question posed to us earlier was, how many play groups are we going to have to establish? What's the minimum number? And because we used 3 different colors for this particular problem, we know that the minimum number of play groups would be 3 in order to separate these students so that they do not have those conflicts as far as the playgroup is concerned. We'd want to put child B and D in a playgroup. We can put children A, E, and G in another group, and then children C and F can be in a separate playgroup, and that should not create any of those conflicts that were reported. Now let's get back to the topic at hand, which is on voting methods. In this lesson, we're going to consider 4 different preferential voting methods: plurality, plurality with elimination, border count, and the method of pairwise comparisons. We will examine approval voting, which is a non-preferential voting method, in the next lesson. When was the last time you voted? Was it a class election, prom theme, or maybe a family decision? Soon you will have the opportunity to participate in local, state, and federal elections. In the United States, most governmental elections use a common form of voting where a voter selects their single choice from the options and does not indicate any further information about preference for the other candidates. The only option is to give your first choice and nothing else. But for less formal voting, like voting on which refreshments to serve at the prom, more information than simply a person's first choice may be desired. Preference ballots allow voters to rank all the available options in order of preference. In this lesson, we will review preference ballots and preference schedules. An example of preference voting might be in an office when the boss wants the employees to make a decision about something that will affect them personally. Let's consider the scenario that an office with 100 employees is asked to take a vote on a theme for the upcoming office party. Instead of doing a majority rules vote, where the option that gets more than 50% of the votes wins, the boss wants to get an idea of how people feel about each of the options. So a preference ballot would be developed that asks the employees to rank the options in order of their own preferences. Using this ballot, a voter can not only indicate which option they like best, but also which they like least and everything in between. Because everyone can rank the options in whatever order they choose, it's easy to see that there are many possible combinations that could result from this form of voting. The multiple outcomes leads us to a preference schedule, which is just a table of the results from the preference ballot. Here's a possible preference schedule for our office party. Notice that tropical is represented by T, picnic with a P, fiesta with an F, and 80s music with an M. As we look at the table, we can see that 25 people picked tropical as their first choice, picnic as the second choice, 80s music as their third choice, and fiesta as fourth choice. We can do a similar thing with each one of the other columns. As we look at this table, it gives us some information very quickly. Notice that fiesta only was voted as a first choice by 30 people. Notice also that it was the fourth choice for 25 plus 16 plus 20 plus 5. So for 66 people out of 100, it was the least favorite choice. Furthermore, we can tell that picnic didn't show up at all for anyone's fourth choice. So we could determine that picnic is the least unfavorite of all of the choices. It's clear that the preference schedule really does give much more information about voters' opinions than a more traditional pick your favorite option style vote. Even though there are many different ways to determine a winner in a preference ballot, there are some rules that apply to all preference voting. A preference ballot does not allow two options to be ranked on the same level. This is called a linear ballot because selection choices must move in a line from one to the next, never plateauing at the same rank. In this way, preference ballots are transitive, meaning that if option A is preferred by a voter over option B, and option B is preferred over option C, then A is automatically preferred over C. Basically, in our office party vote, if a person ranks tropical over picnic and picnic over fiesta, then it is assumed they would also rank tropical over fiesta. Another interesting rule for preference ballots is that relative preferences of an individual voter cannot change if one or more options is eliminated. In our example, let's say that Sally voted in this order: tropical, picnic, 80s music, and fiesta. Now the boss has decided that picnic is definitely out of the question. Sally's relative preferences will not change with this alteration to the overall choices. Her ballot will still indicate that she prefers tropical over 80s music over fiesta. With so much additional information, it can be tricky to determine a winner in a preference ballot election. There are actually many different models used to determine a winner. A winner can be determined by plurality, the option with the most first-place votes, use of the Borda method to assign values to each place ranking, use of plurality with elimination, or automatic runoff until one option remains a majority, and pairwise comparison, which compares candidates to each other in head-to-head contests. It's up to the organizer of the election to predetermine what method will be used to decide the final result. Each of these methods of preference elections will be discussed in detail in this lesson. The plurality method of voting is the most common form of voting in the United States. The basic principle is that the candidate with the most votes wins. However, there really is more to it than that. Have you ever wondered how voting works? Does the winner have to have the majority of the votes, which means more than 50%? Or can the winner just have more votes than anyone else, which is actually called the plurality of votes? When a candidate receives more than half of the votes in an election, we say the candidate has received a majority of the votes. When a candidate receives the greatest number of votes in an election, but not more than half, we say the candidate has received a plurality of the votes. There are many different types of voting methods. However, in this lesson we will discuss the most commonly known method in the U.S., plurality. We will also compare this method to the two most commonly used standards of fairness in voting. Let's check your understanding with this question. Suppose in an election the vote totals are as follows. Andy gets 4,526 first place votes. Lacey gets 1,901 first place votes. And LaJuan gets 2,265 first place votes. Choose the correct statement. A. Andy has a majority. B. Andy has a plurality only. The correct answer is A. There were a total of 8,692 votes in the election. Adding together Andy's votes, Lacey's votes, and LaJuan's votes. 50% of 8,692 is 4,346. So, if someone received more than 4,346 votes, that person would have received a majority. Andy got 4,526 votes, and therefore Andy has a majority. In the plurality method, voters vote for one candidate. The candidate receiving the most votes wins. This method has a couple of advantages. The voter chooses only one candidate, and the winner is easily determined. The plurality method is used in the United States to elect senators, representatives, governors, judges, and mayors. In the United Kingdom and Canada, it's used to elect members of Parliament. Let's look at an example. 4 people are running for student body president. The vote totals are as follows: Aaron with 2,359, Bonnie 2,457, Charles 2,554, and Dion with 2,288. Under the plurality method, who won the election? Charles has the plurality with 2,554 votes. Note that there were a total of 9,658 votes cast. A majority of votes would be at least 4,830 votes. Charles did not receive a majority of votes, but Charles did receive a plurality of votes. Using the plurality method to decide the winner, Charles would win this election. Let's take another example. 3 candidates ran for Attorney General in Delaware in 2002. The vote totals were as follows: Carl Schnee, 103,913 votes; Jane Brady, 110,784 votes; and Vivian Houghton, 13,860 votes. What percent of the votes did each candidate receive, and who won the election? Well, the solution is that a total of 228,557 votes were cast. Schnee received 103,913 votes, and so to figure the percentage that voted for Schnee, we would have to put the number who voted for Schnee over the total number of votes cast. Doing the division and rounding, we get approximately 45.5%. We'd follow the same procedure for Brady, remembering that Brady received 110,784 votes. We can divide that by the total and see that she received 48.5% of the votes approximately. Houghton received 13,860 votes, so figuring her percentage, we would find that she has 6.1%. In this case, Brady received a plurality and is the winner. Now let's look at the fairness of plurality voting. There are 2 common standards of fairness that can be used to evaluate any form of voting. The first is the majority criterion, which states if a candidate has a majority of the votes, then the candidate should win the race. This is not the same as majority rule, which states that a candidate cannot win the race unless that candidate has a true majority of the votes. A true majority would be more than 50%. The plurality method does satisfy the majority criterion of fairness, because if a candidate were to get a majority of the votes, then it's clear the candidate received the most votes and should win. The next standard of fairness is called the Condorcet criterion, and it refers to the standard that the preferred candidate would still win if they had a head-to-head comparison with any other candidate. Consider our previous example. Brady received the plurality vote by receiving the most votes, but she did not win by much. Now, what if all the rest of the voters were actually divided between the other two candidates, but not divided in their desire to stop Brady from winning? What if all of Houghton's supporters would have chosen Schnee if Howter wasn't running? Then Schnee would have had a true majority vote and beaten Brady in this election. So all things being equal, in a head-to-head contest between Brady and Schnee, Brady would not have won. The plurality method does not satisfy the Condorcet criterion of fairness because a head-to-head contest can lead to different results. To counteract this unfairness, often supporters of a lesser-known candidate will insincerely vote for another, more popular candidate in order to ensure that an unwanted candidate does not win. In a sense, you can think of insincere voting as voting against a candidate instead of for your choice. In the board account method, the voters rank all of the candidates. Let's suppose that we have 4 candidates. Then the votes are counted as follows. A voter's last choice gets 1 point. The next to last choice gets 2 points. The next to the last choice gets 3 points. And finally, the voter's first choice gets 4 points. Now, if we have n candidates, we can apply the same procedure. And notice that I have a ... here indicating that these would be the steps between the next to last choice and the first choice. And these would count from 1 to n points. The candidate with the most points wins. The main advantage of the board account method is that it uses more information from the voters. A variation of the board account method is used to select the winner of the Heisman Trophy. You'll recall the pie contest problem from the previous lesson. Recall that in this particular case, the entries were narrowed down to 3 for the final round of the contest. In this final round, each club member ranked the 3 pies. Each first place vote is worth 3 points, each second place vote is worth 2 points, and each third place vote is worth 1 point. Here's a summary of the results. 27 members ranked Al's apple pie first, Chris's cream pie second, and Pat's pecan pie third. 24 members ranked Pat's pecan pie first, Chris's cream pie second, and Al's apple pie third. And 2 members ranked Chris's cream pie first, and Pat's pecan pie second, and Al's apple pie third. Based on the rules, Al's apple pie got 27 first place votes at 3 points each, or 81 points. And 26 third place votes at 1 point each, for 26 points, for a grand total of 107 points. Chris's cream pie got 2 first place votes at 3 points each, or 6 points, and 51 second place votes at 2 points each, for 102 points. The grand total for Chris's cream pie was 108 points. Pat's pecan pie got 24 first place votes at 3 points each, for 72 points, 2 second place votes at 2 points each, for 4 points, and 27 third place votes at 1 point each for 27 points. Pat's grand total was 103 points. We can see from these rankings then that Chris would receive first place, Al second place, and Pat third place using the border count method. Let's take a larger example. 4 people are running for student body president at the University of West Georgia. Voters rank the candidates as shown in the table. Notice that Aaron received 2,359 first place votes, 1,368 second place votes, 2,786 third place votes, and 3,145 fourth place votes. We need to convert the votes to points using the border count method. In this example, I have, because there are 4 places for votes, multiplied first place votes by 4 each time, second place votes by 3, third place votes by 2, and then fourth place votes are multiplied by 1. In this case, I didn't show the multiplication by 1 because we know that any number multiplied by 1 gives us that number in return. Now I want to determine the total number of points that Aaron should receive and all of the other candidates as well. So looking at these totals, we can see that the candidate with the largest number of points who would win this election would be Bonnie. Let's consider the fairness of the border count method. First of all, let's look at the majority criterion. Charles would have won the election using the plurality method because he had more first place votes than any other candidate. Notice that he had 2,554 first place votes. The border count method does not meet the majority criterion of fairness. Let's look at the Condorcet criterion. Bonnie won using the border count method because her point total was highest due to her having many second place votes. Therefore, the border count method does not meet the Condorcet criterion of fairness, where we would match up each of the candidates in a head-to-head comparison. She had many second place votes, giving her the edge when we use the border count method in this particular case. Plurality with elimination is another one of the preference voting methods. The voters choose one candidate, the votes are counted. If one candidate receives a majority of the votes, that candidate is selected. If no candidate receives a majority, eliminate the candidate who received the fewest votes and do another round of voting. This process is repeated until someone receives a majority of the votes and is declared the winner. The plurality with elimination method is used to select the location of the Olympic Games, and it's also used in France to elect the president. Rather than needing to potentially conduct multiple votes, the voters can be asked to rank all candidates during the first election. Then a preference table is used to display these rankings. Let's take an example. 4 people are running for department chairperson. The 17 voters rank the candidates 1st through 4th. Here are the results of the ballots. Under plurality with elimination, who is the winner? As we look at the ballots, we can see that the first ballot shows C, D, A, and B in that order. The second voter chose A, D, C, and B in that order. The third voter also chose A, D, C, and B in that order. We can collapse then some of these ballots to help us make a determination of who the winner is with the plurality of elimination method. As mentioned before, some voters had the same preference ranking. Identical rankings have been grouped to form the preference table below. Notice that the number at the top of each column indicates the number of voters who shared that ranking. So in this case, we had 3 voters who chose the order of their candidates as C, D, A, and B. We had 2 who ranked the candidates A, D, C, and B, and so on as we look at these numbers at the top. The first place votes for each candidate are totaled. Alice has 6 first place votes. In the preference table, you'll see Alice represented by an A, and notice that she was first place on 3 different ballots. We have 2 people who put her first on this particular ballot, 2 people who put her first on this ballot, and 2 who put her first on this ballot, which is how I came up with a total of 6 first place votes for Alice. Bob has 4 first place votes. On this particular ballot, Bob received 2 votes, and on this particular ballot, Bob received 2 votes, for a total of 4. Carlos, represented by C, has 4 first place votes. Here, Carlos has 3 first place votes, and here, Carlos has 1, for a total of 4 first place votes. Donna, who's represented by D, had 2 first place votes and 1 first place vote, giving her a total of 3. No candidate received a majority of votes. Remember, there were 17 people who were voting, and so half of 17 would be 8.5. A majority would be more than 8.5. It would require 9 votes. So, using the plurality with elimination, Donna, who has the fewest first place votes, is eliminated. A new preference table without Donna must be created. Donna is eliminated from each column. Any candidate ranked below Donna will be moved up. So notice in the first column we have 2 people, Alice and Bob, who were ranked below Donna, and now they're going to move up. In the second column, we have 2 people who were ranked below Donna. They also will move up. In the third column, 1 person moves up. In the fourth column, all 3 move up. In the fifth column, 1 moves up. In the sixth column, we just take Donna away. She was the 4th place vote getter. And then for the next column, all 3 candidates move up. In the next to the last column, we just eliminate Donna, and for the last column, 2 candidates move up. The first place votes for each candidate are totaled. Alice has 7 first place votes. Finding the A on the first row, we have Alice has 2 here, 2 more, 1 more, and 2 more, giving a total of 7. Bob has 4, 2 here, and 2 here. And Carlos has 6, 3 here, 2 here, and 1 here for a total of 6. No candidate again received a majority, and so Bob, who has the fewest first place votes, is eliminated. A new preference table without Bob is created. Any candidate ranked below Bob is moved up. So in our first column, we simply eliminate Bob. In the second column, we'll do the same. In the third column, we're going to move up our candidates who ranked below Bob, and so on as we move through the table. The first place votes for each remaining candidate then is totaled. Notice that in this particular case, Alice received 2 plus 2 plus 2 plus 1 plus 2 votes, giving her a total of 9 votes. Carlos has 3 plus 2 plus 2 plus 1, giving Carlos 8 votes. Alice received a majority and is the winner. Let's look at the fairness of plurality with elimination. Remember that the majority criterion says if a candidate has the majority of the votes, then the candidate should win the race. Plurality with elimination voting meets the majority criterion of fairness. With the Condorcet criterion, a winning candidate should be able to win even an individual head-to-head contest with other candidates in the race. Plurality with elimination voting does not meet the Condorcet criterion of fairness. The monotonicity criterion for fairness says if a candidate wins an election and then we change some of the ballots, but only so as to increase the ratings on those ballots of the winning candidate, then that candidate should still win. The monotonicity criterion is not always satisfied by the plurality with elimination method. Now let's look at pairwise comparison. This is our fourth of the preference voting methods. Voters rank all of the candidates. For each pair of candidates X and Y, determine how many voters prefer X to Y and vice versa. If X is preferred to Y more often, X gets a point. If Y is preferred to X more often, Y gets 1 point. If the candidates tie, each get half a point. The candidate with the most points win. This is best understood with an example. 3 people are running for department chair. The 17 voters rank all the candidates as shown in the preference table below. Under the pairwise comparison method, who wins the election? In order to find the solution, we must pair up each of the candidates. There are 3 pairs of candidates to compare: Alice versus Bob, Alice versus Carlos, and Bob versus Carlos. For each pair of candidates, delete the third candidate from the preference table and consider only the 2 candidates in question. Let's see how that works. Looking at Alice versus Bob, we're going to eliminate Carlos in the table. And then we're going to look at the number of times that Alice outranked Bob and count those up. So here we see that Alice outranked Bob with 3 voters, and again here with 2, that's 5, and here with 2 more, 7, and with 1 more here, that's 8, and 2 more here, that's 10. Now let's check to see how many times Bob outranked Alice. Bob received 2 votes here in first place. He outranked Alice here with 2 votes, that gives him 4. And here with 2 votes, that's 6. And finally here with 1 vote, giving him 7. So Alice received 10 first place votes while Bob only received 7. We say Alice is preferred to Bob 10 to 7. Alice receives 1 point. Now let's compare Alice and Carlos. Since we're comparing Alice and Carlos, we eliminate Bob, and we want to see how many times does Alice outrank Carlos. And remember, these tell us the number of votes. So Alice outranked Carlos here with 2, 2 more here, 2 more here, 1 here, and 2 here. Carlos outranked Alice with 3 plus 2 plus 2 plus 1. So Alice receives 9 first place votes while Carlos only receives 8. We say Alice is preferred to Carlos 9 to 8. Alice receives another point. Finally, we compare Bob versus Carlos. And in this instance, we have to eliminate Alice from our preference chart. Now we're going to do the same thing with Bob and Carlos. Bob outranks Carlos with 2 plus 2 plus 2 plus 1 ballots, for a total of 7. Carlos outranks Bob with 3 plus 2 plus 2 plus 2 plus 1, or 10. Carlos receives 10 first place votes while Bob only receives 7. We say Carlos is preferred to Bob 10 to 7. Carlos receives 1 point. The final point totals are Alice with 2 points, Bob with 0 points, and Carlos with 1 point. Alice wins the election when we use the pairwise comparison. Let's look at the fairness of pairwise comparison. First of all, with the majority criterion. As you recall, if a candidate has the majority of the votes, then the candidate should win the race. Pairwise comparison meets the majority criterion of fairness. On the Condorcet criterion, we know a winning candidate should be able to win even in individual head-to-head contests with other candidates in the race. Pairwise comparison meets the Condorcet criterion of fairness. In fact, it models the Condorcet criterion. But you'll recall from the last lesson that those two are not the only fairness criteria. We also have the independence of irrelevant alternatives criterion for fairness. If an election is held and a winner is declared, this winning candidate should remain the winner in any recalculation of votes as a result of one or more of the losing candidates dropping out. This particular criterion is not always satisfied by any of the 4 voting methods that we have discussed with preference voting. Let's consider a question to check your understanding. An election was held and a preference table was created. Notice in the table that ballots have been collapsed for those who put C first, A second, and B third. We know that there are 7 such ballots. There are 12 people who voted B first, A second, and C third, and so on. Candidate B was declared the winner. What voting method could have been used? Select all that apply. A, plurality, B, Borda count, C, plurality with elimination, and D, pairwise comparison. Using plurality, the winner would be candidate C. Notice that with candidate C, we have ballots here and here that show C as being the first choice. So we have to add 7 plus 9 for a total of 16. That gives candidate C a plurality of votes. And if we're using the plurality method to determine the winner, candidate C would be chosen. Using the board account method, let's determine who the winner is. Remember that we're going to assign 3 points for first place, 2 points for second place, and 1 point for third place. As we look at our preference table, we'll notice that A received 10 first place votes. A also received 28 second place votes. And I got the 28 by adding the 7 plus the 12 plus 9. And notice that for third choice, there isn't an A at all. So to determine the number of points that A gets, I multiply 3 times 10 because there were 10 first place votes for A, 2 times the total of 7 plus 12 plus 9, and then that gives me 30 plus 2 times 28, or 30 plus 54, which is 84. I do the same thing for candidate B. Notice that candidate B has 12 first place votes, 10 second place votes, and 7 plus 9 third place votes. So I have weighted each of those based on the rank, and this turns out to be 72 points for candidate B. The same thing is done for candidate C. So notice that C has 7 plus 9 first place votes, so those are going to be multiplied by 3. Candidate C has absolutely no second place votes, and candidate C has 12 and 10 third place votes to get 1 point for each of those. So that gives candidate C a total of 70. In this case, the candidate with the largest number of points wins, and candidate A would be the winner. Let's determine who the winner would be using the plurality with elimination method. Recall that for this particular method, we have to determine who has the fewest first place votes. Our candidates are A, B, and C. Let's consider them in alphabetic order. Candidate A has 10 first place votes. Candidate B has 12 first place votes, and candidate C has 7 plus 9 first place votes for a total of 16. Comparing 10, 12, and 16, we know that A has the fewest first place votes. We will eliminate A first because A has the fewest first place votes. Any candidate ranked below A then is going to be moved up. Now we can check candidate B versus candidate C. We know that candidate B is ahead of C with 12 voters in this ballot and with 10 voters on these ballots for a total of 22. Candidate C is ahead of candidate B with 7 ballots plus 9 ballots, or 16. Therefore, B is the winner when using the plurality with elimination method. Finally, let's use pairwise comparison to determine the winner. Recall that with pairwise comparison, we have to take each pair of candidates and put them head to head. Therefore, we're going to have to compare A versus B, A versus C, and B versus C. Let's take the first head-to-head matchup, A versus B. Notice that A is ahead of B on this particular ballot, and there were 7 who voted that ballot, and on this ballot with 10, and on this ballot with 9. Therefore, we have 7 plus 10 plus 9, or 26 for A. Then B is ahead of A in only one instance. Therefore, A gets the point. Let's look at A versus C. In this column, A is not ahead of C, but in this column she is, so she has 12 ballots with A ahead of C here, and on this ballot A is ahead of C as well with 10, so that gives a total of 22. Now looking at the other ballots, C is ahead of A with 7, and C is ahead of A with 9, giving a total of 16. In this instance, A gets a point. Let's check B versus C. B is ahead of C on these ballots, so there are 12 of those. B is ahead of C on this ballot, or 10 of those, for a total of 22. C is ahead of B on the other 2 ballots, so we have 7 plus 9, or 16. In this case, B gets a point. So, A has 2 points, B has 1 point, C has 0 points. That means that A is the winner using pairwise comparison. Let's be sure to answer the question. Remember, the problem said that an election was held and a preference table was created. Candidate B was declared the winner. What voting method could have been used? Select all that apply. As you recall, with the plurality method, candidate C was the winner. With the border count method, candidate A was the winner. With plurality with elimination, candidate B was the winner. And in pairwise comparison, candidate A was the winner. In this lesson, you have learned to understand preference voting, to determine the winner of an election when using these types of methods, and specifically the methods that we considered were plurality, border count, plurality with elimination, and pairwise comparison. You also learned to determine the fairness of each method. You may refer back to this video as you complete the practice assignment for this lesson.